Hello everybody. We are doing our simulations lab part 2. We're going to be doing 3 simulations now. I'll be demonstrating them for you, and you'll be taking data. You'll be actually collecting data today. The last of the simulations you'll have to do on your own using material that you'll have to be able to scrounge up for yourself. All right. So in the first 2 simulations, I don't expect you to have these things. These are centicubes. And so if you look at them, they've got a little nub on the top, a little outie belly button on the top, and otherwise it's a 6-sided cube. If you roll it on the table, there are 3 possibilities of the way it could land. It could land the way that it landed here, with that little outie belly button coming off to the side. Let me zoom in for you. Okay, so you could have it with the button on the side. That would call that a side result. You could have it with the button coming straight up, call that an up result, or it could theoretically land so that the button is pointing downward. That would be a down result. Okay. I've taken the liberty of marking the cubes with a little dot on the top, which will make it easier for you to score. The other side, the down side, is going to be marked with a little circle. We'll do this off screen, a circle, so that you can see when it's sideways or when it's an up. It'll make it easier for you to score them. And so get these out of the way, and we'll show you how I've got 50 of these cubes that will be rolling on the table to simulate life histories. Okay. Now, for the first simulation, we're going to be starting off with cubes. These cubes are going to be representing our population of, well, whatever it is we're simulating. And I'm going to be rolling them out. We're going to be starting with a population size of 50. So all 50 of these guys are little animals, cubical animals, if you like. And so we've got 50 young of the year, age 0, all right? And so 50 individuals are surviving to age 0, and you could mark that into your data table. Okay, and the rules of survival from one year to the next will be that in order to survive, you have to land with your button to the side. Any individual that lands with a button up or down will be a mortality, a casualty. And so we're going to be rolling these guys out. I'll do the first generation for you, and I'll count out the things because I expect that you might be finding this a little bit unfamiliar initially. But let's go ahead and do this. Okay, and yes, you can see all of them. These 2, they decided to mate, so I'm going to have to separate them and re-roll them out. Okay, so I'm hoping that you can see this, but this one is up, this one is up. These 2 are mating. I'll re-roll them again. Okay, so we have up, up, it's a down, it's an up, it's an up, it's an up, 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 up. So all these ups are out. Yes, and so it looks like we have 11 casualties. Everybody else is a survivor. And so for age 1, at age 1, we have 39 survivors. Okay, now I'll just leave the dead ones off to the side, and I'm going to re-roll the 39 survivors. And from this point, you're going to have to keep track of the numbers. I will pull out the dead ones and re-roll the live ones, but you only need to follow along on the screen and record the numbers as you see them. what it is, but the yellow one and the white one seem to be pretty randy. Okay, and yes, you can see all of them. Those are mating again. These are mating. Okay, I've gotten to the point where I've got 3 survivors, and that's when it's called a simulation B. Okay, got this data down? Okay, so what you'll want to do is to use a natural log transform on the number of survivors to age, well, whatever the age is, and plot that against the age itself. And that's how we're going to be getting your very first age-specific survival curve. Okay, make sure to use the natural log of the numbers. It doesn't give you an accurate picture unless you do. Okay, go ahead and do that in Google Sheets or something like that. It should be pretty easy. Okay, so for the next simulation, called a simulation B, first simulation could be simulation A. Simulation B, we're going to be starting off with survival being really crappy. Kind of think oysters. Okay, and so instead of doing it the same way, at least for the first year, in order to survive, you have to land with your with your belly button pointing downwards. Okay, and so you can't see that terribly well because the angle is pointing away from you. It's leaning away from you, but if it were leaning towards you, you could see that that's an up position. So the up position, the belly button down position is going to be the least likely of all the outcomes because it tends to be relatively unstable. You might say that all 6 sides of the cube are equally likely, but no, the down one is going to be a little bit less likely than all the others because if you're kind of on the verge of being down and then you get a little bit, there's any kind of disturbance, you're going to be ending up with your button pointing to the side. All right, so we know that down is the least likely outcome of all of them. And so what we're going to be doing is saying, well, in the first year of life, you have to survive. The only way you survive is by having your button pointing in the down position. Okay, that's going to give us a really low survival rate. And so in order for this to work, we need to have a much larger starting population size. You know how oysters are starting out with 50 million to 60 million babies per female per year. We're going to be starting out with 500. And so we've got 50 cubes there. There are 50 cubes. We're going to be rolling them 10 times. So we'll be rolling 50 cubes 10 times. I'll be keeping track of the number of downs that we have. Okay, and I'll be writing them down. I'll tell you what the results are, but you'll get to see what's going on as I do it, right? And so I'm going to be rolling 10 times, 50 cubes, and I'll be keeping track of the number of downs, and that will give me the number of survivors that I have to year 1. So here's roll 1 out of 10. These guys are not mating. These guys are not mating. Okay, I gotta find my pen. I'm gonna write this down. Looks like I've got 2 in first roll. Here's roll 2. These guys have a little 3-way going. Break that up, break these guys up. Two. Roll 3. Roll 4. Roll 5. Roll 6. Roll 7. roll 8. Roll 9. Last one, roll 10. Okay, so by my count, we had, out of 500 Young of the Year, a total of 22 survivors. And so what I'm going to do now is I'll count out 22 cubes, and that will be my starting population. Okay. There's 6, 10, 20, 22. Double check my counting. Okay, it's 22. Now, in the next generation, and the next, not the next generation, the next year, in the second year of life, in order to survive, you must land either with your button pointing downwards or upwards. So down or up is a survival, and side is going to be dead. That was down. Looks like everybody else's side. So it looks like we are now down to 6 survivors. Okay, and from year 2 onward, we're going to be using the same rules that we had for simulation A. And so up or down is mortality, and side is survival. And at this point, I'll just let you keep track of the data. I'm just going to roll them. Over here so you can see. Okay, why don't we just end that one where we had 2 survivors. So basically it went down to 2 pretty quickly. we're just going to stop the simulation there. See, once you get down to a really small number, then random chance tends to have a larger influence over the outcome, and you're aware of that from our discussions of random genetic drift. So we ended up with a long sequence of rolls where I only had two little cubes, and they ended up both side for several rolls in iteration. Okay, that's totally expectable, but it's not representative of the actual likelihoods of the different outcomes. So what we're going to do is we'll just go through a very small number of generations. Obviously, there are 500 survivors to age 0. We had 22 survivors to age 1, and 6 survivors to age 2, and then we'll just keep on going only until we get to the number of survivors equal to 2. The very first year, the first year in which we had 2 survivors, and from that point, we'll just end the simulation. Okay, and so again, like you were doing before, you will take the natural log of the number of survivors to age, whatever the age is, and plot that using Google Drive, Google Sheets, and that should give you the result, our experimental outcome for simulation B. All right, now for simulation C, you're going to be doing this one at home, okay? And you will need some kind of bubble solution. Okay? Now, this is just the bubble solution that our lab techs bought for me, and what you're going to be doing will be blowing bubbles, 30 bubbles, and capturing the bubbles at the end of the wand. But at the time that you blow the bubbles, that's going to be the time of birth. Okay? And so you'll be blowing a bubble, capturing it on a wand. The age begins when you actually blow the bubble, and you'll be recording the time of death. And you'll be doing this for 30 bubbles, and death means the bubble pops. Okay, so I'll give you a little bit of a demonstration. This one was in backwards. Okay. Okay, I'll be blowing the bubble now. Try that again. Blowing the bubble now. Capture the bubble and just hold on to it on the wand. And you should have a stopwatch going. I'll be playing a stopwatch in the sidebar so you can be seeing how long it takes the bubble to die. And when you do this, you want to keep the bubble size approximately the same for all 30 in your sample, because smaller bubbles and larger bubbles are different in terms of the stability of their the surface film. And if you do this for long enough, you'll realize that the colors of the bubbles change. You might see that it's getting a little bit more amber at the top. That's a sign of bubble aging. Eventually, you'll find that the bubble gets really thin at the top, and just before it pops, you can almost see it get diaphanous. That's a good word for you. Okay, I'm going to go ahead and speed ahead. I'll be holding the bubble here until it pops, but I'm going to speed the video so that you don't have to watch the bubble for the entire time. Okay, I can see it's getting ready to pop because the top surface is getting a little bit irregular. Getting super thin. There we go. Okay, that took a really long time. It was probably a little bit less time than it would have taken had I chosen a smaller bubble. It was probably a little bit more time than it would have taken had I held the bubble on top of the wand as opposed to hanging down from the wand. Hanging down from the wand, I think what happens is that the top of the bubble, where it tends to get thinner a little bit more quickly, gets continually replaced by some of the bubble fluid that is there in the wand. There might be some continual replenishment of the thickness of the bubble at the top. So if you want your bubbles to last less time, it'll mean less time for you to be active in this laboratory. You might want to blow the bubbles so that the bubbles are sitting on top of the wand. All right. So do this. Most of you will have some bubble solution someplace in the household. If you've got glycerin and dishwashing liquid, you can make your own bubble solution. You can Google up the recipe online. It actually doesn't matter how good your bubble solution is. It might be even a little better for you if you've got some cheap bubble solution where the bubbles don't last very long. Try not to count the bubbles that pop as a result of capturing them on the wand, though. That's going to kind of give you one specific cause of mortality that we don't necessarily want reflected in our data. Okay, so 30 bubbles, record the time of death. Now, what you want to realize is that the data that we're recording here are very different from the kind of data that you'll be getting from the first two simulations. Simulations A and B, we are actually recording the number of survivors to a given age. Okay, with the bubbles data, we're not doing that. You've got to figure out how many bubbles are surviving to a given age. And I'll let you think about how to do that. That'll be part of your challenge for this laboratory, figuring out how to convert a list of bubbles, how long they lived, converting that into a number of survivors to specific ages. You could create benchmark numbers of seconds. You can make 10 seconds, 20 seconds, 30 seconds, 40 seconds. You can make those the equivalent of 1 year, 2 year, 3 year, 4 year, etc. Okay, leave that up to you to figure out how that's going to work. Okay, now after you do that with the bubbles that you've done indoors that you're capturing on the end of your wand, I would I'll ask you to do the same thing for another 30 bubbles, but outside. Yes, outside. Go outside, blow a bubble, start the stopwatch, but don't capture it. Just let the bubble do what it naturally does. And record the time it takes for the bubble to pop. Okay? And you'll want to use bubbles of about the same size that you did in your indoor trials. You don't want to bias the sample by selecting the bubble that lasts the longest. If you blow 10 bubbles and pick the one that is still there after the initial pulse of mortality, then you're actually creating a non-random sample. You're creating a biased sample, and you don't want to do that. So what you would like to do is to blow a bubble, maybe a single bubble that's about the same size that you are blowing in the indoor portion, and then track the fate of that bubble. How long does it last? How old is it when it dies? Okay, and you'll be bringing those data in after you convert the results into survivors versus time, or age, or versus the number of survivors to that age. And so for both of your samples, you should have at age 0, 30 bubbles surviving to age 0, because we're starting off with 30 bubbles. And so you'll do the same thing we did before. Take the natural log of the number of survivors. So at age 0, you would have the natural log of 30 as the first data point in your age-specific survival curve. Okay. And then we'll continue this discussion with what we typically get for age-specific survival for the 3 graphs that we have in today's lab. All right?